All right, so get this. Imagine an AI that learns on the fly, right? Like it can adapt to any task you throw at it.
Yeah, sounds kind of sci-fi, doesn't it?
It does, but it's closer to reality than you might think.
Definitely. This whole idea of self-adaptive LLMs is really pushing the boundaries of what AI can do, could be a total game changer.
Absolutely. And that's what we're diving deep into today.
Yeah, we're looking at this research paper from Sakana AI. It's called TRANSFORMER2, Self-Adaptive LLM.
It's pretty dense stuff, but don't worry, we're going to break it down.
Make it clear, even fun, maybe.
Exactly. So, the researchers start by addressing this big problem with current LLMs, the whole one-shot training method,
Right. Basically, they're trained just once on this massive data set.
which takes tons of resources and can actually lead to, well, performance issues.
It's true. There can be hiccups along the way.
Yeah. I was thinking it's kind of like cramming for a giant exam, you know, one that covers every subject imaginable. You might pass, but
But you're not going to be an expert in anything specific. And traditional LLMs, they kind of struggle with that, truly excelling in specialized areas. But that's where these self-adaptive LLMs come in. The idea is that they're designed to learn and adapt like in real time,
wow.
just like our brains do.
That's incredible. I mean, think about it. We switch between tasks all the time, right? Reading, problem solving, texting.
All the time.
We don't even think about it. So these self-adaptive LLMs are trying to mimic that flexibility.
That's the goal. They want these like specialized expert modules that can activate as needed.
Interesting.
Similar to how different parts of our brains, light up when we do different things.
I see. And does that mean they could even learn how I learn best?
Ooh, that's a good question.
Like my specific learning style.
That kind of gets at one of the key challenges with creating truly self-adaptive LLM scalability. Like, how do you manage all these expert modules
Right.
without the model becoming, well, insanely huge and complex?
Yeah, that makes sense. And wouldn't they need a way to combine all those different modules so they work together?
Exactly. It's another hurdle. Compositionality. You need a way to make all those modules work together smoothly. And this is where the research paper gets really interesting.
Okay, tell me more.
The Sakana AI team introduces this technique called singular value fine-tuning,
Okay.
SVF for short. And it's a really clever way to adjust the model's behavior, but without needing to train a ton of extra parameters.
So instead of retraining the entire model, which would take forever,
Right.
they're just fine-tuning specific parts of it.
Exactly. Think of it like instead of changing the entire structure, they're just fine-tuning specific values within the model's weight matrices.
I see.
And this is a big deal. It makes fine-tuning way more efficient. I mean, way fewer parameters than other techniques, like LoRA, for example.
So could AI become more accessible, even run on our phone someday?
Possibly. That's one of the exciting things about SVF.
Wow.
And there's another big advantage. It acts as a natural regularizer, prevents the model from, overfitting to specific data sets.
Oh, so it can generalize better to new situations.
You got it.
Okay.
Now let's talk about how they trained these expert modules.
Yeah.
Instead of using traditional labeled data, TRANSFORMER2 uses, get this, reinforcement learning.
Reinforcement learning, or RL.
Yeah.
RL.
Can you break that down for those of us who don't speak fluent AI?
Sure. Think of it like training a dog.
Okay.
You give the dog a treat when it does a trick correctly,
Right.
encouraging it to repeat the behavior.
I see.
RL is similar. It rewards the model for successful outcomes,
Okay.
guiding it towards the desired results.
So instead of giving it a textbook, you're giving it virtual treats.
Basically,
That's pretty cool.
it's a powerful way to train models based on their actual performance.
Okay, so we have these efficient, adaptable, expert modules trained through reinforcement learning. But how does TRANSFORMER2 actually use them?
Right, good question. That's where their 3 adaptation strategies come in.
3 adaptation strategies.
Think of them like different tools in the model's toolbox. I'm intrigued. Give me the rundown. What's the simplest strategy?
Okay, the simplest is prompt engineering. Basically, giving the LLM an extra little prompt, asking it to classify the task. And then based on that, it selects the appropriate expert vector.
So adding a sticky note that says, hey, AI, you'll need your math skills for this one.
Exactly.
Simple but effective.
Right. Then there's the classification expert strategy.
Okay.
This one uses a separate module, also trained with SVF, and it's specifically designed to identify the task even more accurately.
So it's like a specialized receptionist.
Right.
Directing calls to the right department.
You got it. And make sure the right expert module is called upon for the job. And then finally, we have the most sophisticated strategy, few-shot adaptation.
Few-shot adaptation. I feel like I've heard of few-shot learning. Doesn't that have something to do with, like, how humans learn new things?
You're exactly right.
We don't need tons of data, just a
Yeah.
few examples to get started.
Exactly. Few-shot adaptation is all about leveraging a small set of examples from the specific task to dynamically combine those expert vectors.
Wow, that's amazing.
It's like the LLM is doing some on-the-fly learning, you know?
So it's like taking a few cooking lessons and then whipping up a gourmet meal.
Exactly. Figuring out the best combination of skills to solve the problem.
Pretty impressive. So how did they actually test all of this?
Well, they designed a series of tasks that the AI had never seen before.
Okay, so they threw some curveballs at it
Mhm.
to see if it could think on its feet.
Right. For example, they used math, which is a data set of like university-level math problems.
Wow, tough crowd.
And they also tested it with Human-Evil for code generation and ARC challenge, which is, well, a more difficult reasoning benchmark.
So they really put it through the ringer. Did it pass the test?
Well, all three strategies actually showed improvement over the baseline LLM, but there were some clear differences, like prompt engineering that provided modest gains.
Yeah, which makes sense because it's the simplest approach.
It is. It's like giving the AI a little nudge in the right direction.
Right, you're not expecting a giant leap forward, but any improvement is good.
Exactly. Then there's the classification expert strategy. That performed noticeably better,
Okay.
which shows the value of having that dedicated module.
Right, accurately identifying the task.
Yes, like having an experienced guide, you're more likely to reach your destination efficiently.
Exactly. And then the star of the show, I'm guessing, was few-shot adaptation.
Yeah, it consistently outperformed the other strategies, really demonstrating the power of dynamically combining those expert vectors.
It's like the AI is learning to conduct a symphony, bringing in different instruments at just the right moment.
I like that.
Now, you mentioned earlier that these expert vectors could potentially be transferred to different LLM architectures. Is that, like, too good to be true?
It's definitely a groundbreaking finding.
Yeah. Imagine being able to take those specialized modules and just plug them into different models.
It could revolutionize the way we develop and share AI tech.
Mind-blowing. It's like taking the engine from a race car and putting it in a minivan. Suddenly, you've got this supercharged family vehicle.
Right.
But if we're being honest, how realistic is it to think we can just swap AI parts like that?
Well, there are definitely challenges. I mean, different LLMs have their own unique architectures.
Right. It's like translating a complex concept from one language to another.
Exactly.
You know, some nuances might get lost in translation.
Right. So it's not quite plug and play. There's still fine-tuning involved, optimization.
It's like a heart transplant.
Yeah.
Sometimes it works, but you have to consider biological compatibility.
Right. The researchers did find some promising results, but their tests were limited to models with, similar architectures.
Yeah.
So more research is needed to see how well those expert vectors can be transferred to, vastly different models.
Makes sense, but the potential is there.
It is.
We can crack the code of cross-model transfer. The possibilities are incredible.
I agree. Incredible opportunities for collaboration and innovation.
Okay, before we get carried away dreaming about the future of AI, let's talk limitations. What were some of the challenges they encountered?
Well, one of the key things they highlighted is that those expert modules, they're inherently limited by the knowledge in the base model.
So if the base model is missing something, those expert modules can't just magically create it.
Exactly. It's like having a team of expert bakers.
Okay.
They can create amazing pastries, but only if they have the right ingredients.
So if the base model is missing key information, the expert modules are basically stuck.
Yeah, that's a great way to put it.
Right.
They can refine and enhance what's already there, but they can't, invent new knowledge or skills.
That makes sense. And what about the efficiency of the adaptation process itself? Especially those few-shot adaptations? Those seem like they could be pretty computationally expensive.
Yeah, it's a valid concern. There's definitely a trade-off between performance and efficiency.
Okay.
The more complex the adaptation strategy, the more computational resources it needs. It's a balancing act. You want the AI to be adaptable, learn quickly, but you also have to be realistic about the time and processing power involved.
So it's like investing in a high-quality tool.
Exactly.
It might cost more upfront, but it will save you time and effort in the long run.
Precisely. And plus, there's always room for improvement Researchers are always trying to find ways to optimize the adaptation process,
That's reassuring.
make it faster, more efficient.
Okay, cool. So are there any other areas where they see potential for future research?
Well, one exciting direction is exploring how model merging techniques could be integrated with Transformer 2.
Model merging.
Yeah, this involves taking multiple specialized models and combining them into a single, even more capable base model.
So like building an AI dream team
Exactly, each member with their own area of expertise.
and then somehow merging their collective knowledge into one super intelligent being. Is that even possible?
Well, it's an active area of research. The possibilities are definitely tantalizing.
Yeah. Imagine creating AI systems with an even wider range of knowledge and skills,
Exactly.
making them even more adaptable.
Capable of tackling those really complex challenges.
So instead of just having specialized modules, we could have a base model that's already a jack of all trades,
Right.
and then it can learn even more. That's pretty wild.
It is. And another area for future research is developing even more efficient adaptation techniques.
Okay.
In this study, they mainly use something called the cross-entropy method for few-shot adaptation. But there might be better approaches out there.
So we're not just talking about improving the AI itself,
Yeah.
but also finding better ways to train it, help it learn faster.
Exactly. It's all connected.
This whole field is moving so fast.
It really is. And as research progresses, we can expect to see even more sophisticated, more efficient self-adaptation techniques.
Yeah, pushing the boundaries of what AI can do.
For sure.
It feels like we're moving away from the idea of AI as a rigid tool and towards something more dynamic, more collaborative, like a partner that's constantly learning and evolving alongside us.
I couldn't have said it better myself.
Okay, so let's shift gears a bit. Let's talk about real-world applications.
Okay.
Where could self-adaptive LLMs make a real difference in our lives?
Well, I think the possibilities are vast. I mean, they span across so many industries. Like, for example, in education, we could see personalized AI tutors that adapt to each student's learning style and pace, provide customized lessons, feedback,
It would be revolutionary.
Right, make education more engaging and effective for everyone.
Yeah, and it could make learning more accessible, too.
For sure.
Especially for students who struggle with traditional teaching methods.
Absolutely. And it could even help teachers
Yeah.
by providing personalized support and resources.
I like it. What about healthcare?
Healthcare is another great example. Self-adaptive LLMs could help doctors with diagnosis, treatment planning. Imagine an AI that can analyze all this medical data, identify patterns, provide personalized recommendations.
So it would be like having a team of medical researchers at your fingertips.
Exactly. Helping doctors make more informed decisions, maybe even leading to faster, more accurate diagnoses.
That's incredible.
And let's not forget about the creative industries.
Oh, yeah. How could AI impact creativity?
Imagine AI assistants that can collaborate with artists, writers, musicians.
Interesting.
Help them break through creative blocks, explore new ideas.
That would be amazing. It's like having a brainstorming partner who always has fresh perspectives.
Exactly. Always pushing you to think outside the box.
Okay, last one. What about research and development?
Oh, that's a big one. Self-adaptive LLMs could help accelerate scientific discovery. Imagine an AI that can analyze complex data, identify patterns, generate hypotheses.
It'd be like having a tireless research assistant working 24/7.
Exactly.
This all sounds incredible, but I have to ask, with any powerful technology, there are potential risks. As AI becomes more capable, more autonomous,
Yeah.
how do we make sure it remains beneficial, that it doesn't pose a threat?
That's the big question. It's one that researchers and ethicists are actively grappling with.
Yeah.
As AI becomes more integrated into our lives, it's crucial that we develop, ethical guidelines, safety protocols
Absolutely.
to ensure responsible development and use.
So it's not just about making the technology work.
Right.
It's about making sure it works for good. Sounds like there are a lot of unanswered questions.
There are.
A lot of challenges ahead.
Definitely. But that's also what makes this field so exciting. We're constantly learning, pushing the boundaries of what's possible.
All right, before we move on, I want to revisit that idea of cross-model transfer. You said it was tested on models with similar architectures. What makes it so challenging to transfer these expert vectors to models with completely different structures?
Think of it like trying to explain a complex concept from one field of study to another. You need to find a way to translate the knowledge, make it relevant, make it understandable in a different context.
So, like trying to teach a dog a trick that was originally designed for a cat.
Yeah, exactly.
Their brains work differently? You can't just directly transfer the instructions.
Right. Different LLM architectures have, unique ways of representing and processing information. To make cross-model transfer work seamlessly,
Yeah.
we need more sophisticated techniques to bridge those gaps and make sure that the knowledge embedded in those expert vectors can be effectively applied in a different model.
So it's like finding a universal language for AI.
Yes.
So those specialized modules can be shared and adapted across a wide range of models.
That's a great way to put it. And if we can achieve this,
Yeah.
it could unlock even greater potential for collaboration and innovation in AI development.
Okay, let's zoom out for a second.
Okay.
What does the development of these self-adaptive LLMs tell us about the future of AI?
Well, I think it suggests that we're entering a new era.
Oh,
One where these AI systems are no longer static tools, but dynamic learners, capable of evolving and adapting to new information, new challenges.
it's like the difference between a traditional textbook and a personalized interactive learning platform.
Exactly.
Yeah.
One that adjusts to your needs, your goals.
Yeah.
And this shift has profound implications for how we interact with and utilize AI in the future.
Absolutely. We could see AI assistants that truly learn our preferences, anticipate our needs,
Right.
help us navigate our complex lives in ways we can't even imagine.
It's exciting.
It's both exciting and a little daunting.
I agree.
But as we create increasingly sophisticated AI, we have to remain mindful of the ethical implications.
Absolutely. As AI becomes more powerful, we need to make sure that it aligns with human values,
Yeah.
that we use it responsibly for the benefit of all.
Well said. Now, before we move on to the final part of our deep dive,
Mm.
I have a question that's been bugging me. You mentioned those expert modules are limited by the knowledge of the base model.
Right.
What if we can create base models that are inherently designed to be adaptable? That continuously learn from new experiences.
Ooh, that's a brilliant question. That takes us to the heart of what it means to create truly intelligent AI systems. Because current LLMs, even with those self-adaptation techniques, they rely on a relatively static knowledge base.
It's like they have a fixed library of information,
Yeah.
even if they're really skilled at using and combining it in new ways.
Right.
But what you're suggesting is a base model that's more like a living organism, constantly learning, growing, expanding its knowledge base.
Exactly. It's a grand challenge, and it requires a fundamental rethinking of how we design and train these AI systems. We need to move beyond those current paradigms and explore models that are capable of lifelong learning. It's a fascinating problem, incredibly complex.
I can only imagine. This concept of lifelong learning in AI and feels like the next frontier, the key to unlocking truly intelligent systems, ones that can grow and evolve alongside us.
I agree. Definitely a topic ripe for further exploration.
Well, on that note, I think it's time to move on to the final part of our deep dive. We'll delve into some additional insights and questions, and maybe get a glimpse of what the future holds for these self-adaptive LLMs.
So those are the first two strategies, prompt engineering and the classification expert. But there's one more, and this is where things get, well, even more interesting.
Okay, lay it on me.
It's called few-shot adaptation, and it's all about using just a handful of examples from the task at hand, like a few quick lessons to dynamically combine those expert vectors we've been talking about.
Few-shot adaptation. So is it kind of like how we humans learn new things? Like, we don't always need mountains of data, just a few good examples to get the gist.
Exactly. It's really mimicking that human ability to grasp new concepts quickly.
That's pretty amazing. So it's like the LLM is doing some real-time learning, figuring out the best combo of skills to solve the problem right in front of it.
You got it. It's constantly adapting and refining its approach.
So how do they test all of these different strategies? What kind of challenges did they throw at the AI?
Well, they designed a bunch of tasks that the AI had never encountered before, to really test its adaptation skills.
Ooh, so they threw some curveballs at it, huh?
Yeah.
Made it think on its feet.
Exactly. They used a few different data sets. For example, they had one called Math, which is a collection of university-level math problems.
Yikes, that sounds tough.
Yeah, it was no walk in the park. And they also use Humaneval, which focuses on code generation, and ARC Challenge, which is a more, a tougher reasoning benchmark.
Okay, so they really put this thing through its paces. Did it pass with flying colors?
Well, all three strategies actually showed improvement over the baseline LLM, which is impressive in itself, but there were some interesting differences in how they performed.
Okay, I'm curious. Break it down for me.
Sure, so prompt engineering, the simplest approach, led to modest gains, which makes sense.
Yeah, it's like giving the AI a little hint, pointing it in the right direction.
Right, you're not expecting a massive leap forward, just a little boost.
Makes sense.
But then, the classification expert strategy, remember that specialized module for identifying tasks? Well, it performed noticeably better.
Okay, so having that dedicated expert on hand really made a difference.
It did. It's like having a seasoned guide leading the way, you know? You're more likely to reach your destination efficiently.
That's a great analogy. And what about few-shot adaptation? How did that perform?
Well, as you might have guessed, it was the star of the show. It consistently outperformed the other two strategies, really highlighting the power of combining those expert vectors on the fly.
Wow, that's pretty incredible. It's like the AI is learning to conduct an orchestra, bringing in different instruments at just the right moment to create this beautiful symphony.
I love that analogy. It captures the essence of what few-shot adaptation is all about.
Now, earlier we talked about the idea of transferring these expert vectors to different LLM architectures. You even mentioned it could revolutionize AI development, but let's be real, how feasible is that? Can we really just swap out AI parts like Lego blocks?
It's definitely a groundbreaking concept, but there are some real challenges. Remember, different LLMs, they have their own unique architectures, their own ways of processing information. It's kind of like trying to translate a complex idea from one language to another.
Right, like some things might get lost in translation, right?
Exactly. It's not as simple as just plug and play. There's still a lot of fine-tuning and optimization involved to make it work seamlessly.
So it's like trying to transplant an organ. You have to make sure everything is compatible.
Yeah, that's a good way to think about it. And the researchers, they did find some promising results, but their tests were limited to models with similar architectures.
So more research is needed to see how well this transferability works across vastly different models.
Definitely. But the potential is huge. I mean, imagine being able to take these specialized AI modules and plug them into all sorts of different models.
It would be like having a universal toolbox for AI, allowing us to share and reuse these expert skills across the board.
Exactly. And that kind of collaboration could really accelerate the pace of innovation.
Okay, before we get too carried away dreaming about the future, let's step back and talk about some of the limitations. What are some of the challenges the researchers encountered?
Well, one of the key things they pointed out is that these expert modules, they're limited by the knowledge contained within the base model. They can only work with what they've got.
Right, so it's like having a team of expert chefs, but if they don't have the right ingredients, they can't whip up a masterpiece.
Exactly. They can refine and enhance existing knowledge, but they can't create something from nothing.
Makes sense. And what about the efficiency of the adaptation process itself? It seems like those few-shot adaptations in particular could be pretty resource-intensive.
That's a valid point. There's definitely a trade-off between performance and efficiency. The more complex the adaptation, the more computational power you need.
So it's like a balancing act, right? You want the AI to be adaptable, but you also have to consider the cost and time involved.
Exactly. But in many cases, that one-time adaptation cost might be worth it if it leads to significant performance improvements down the line.
It's like investing in a high-quality tool. It might cost more upfront, but it will save you time and hassle in the long run.
Precisely. And the good news is researchers are constantly working on ways to optimize the adaptation process, making it faster and more efficient.
That's good to hear. So are there any other areas where they see potential for future research besides improving the efficiency of the adaptation process?
Oh, absolutely. One exciting direction is exploring how model merging techniques could be integrated with Transformer2. This involves taking multiple specialized models and combining them into a single, even more capable base model.
So it's like assembling an AI dream team, each member with their own unique expertise, and then merging their collective knowledge into one super intelligent being.
Exactly. It's an active area of research, and the possibilities are pretty mind-blowing. Imagine AI systems with an even broader range of knowledge and skills, capable of tackling even more complex challenges.
So instead of having specialized modules that excel at specific tasks, we could have a base model that's already a jack of all trades, ready to learn even more.
Precisely. And that would open up so many new possibilities for AI applications.
That's incredible. And what about those adaptation techniques? Are there any other promising avenues for improvement there?
Definitely. You know, in this particular study, they used a method called the cross-entropy method for few-shot adaptation. but there might be even better, more efficient approaches out there waiting to be discovered.
So it's not just about improving the AI itself, it's also about finding better ways to train it and help it learn more effectively.
Absolutely. It's all interconnected.
This whole field is moving so fast, it's hard to keep up.
I know, right? It's an exciting time to be involved in AI research. And as research progresses, we can expect to see even more sophisticated and efficient self-adaptation techniques pushing the boundaries of what AI can achieve.
It's incredible to think how far we've come, and it's even more exciting to imagine where we might go from here.
Hmm.
It feels like we're moving away from the idea of AI as a rigid, pre-programmed tool and towards something much more dynamic and collaborative.
I agree. It's like AI is becoming more of a partner, constantly learning and evolving alongside us.
Okay, let's shift gears a bit and talk about the real-world implications of all of this. Where could these self-adaptive LLMs actually make a difference in our lives?
The possibilities are vast, really. I mean, think about education. We could have personalized AI tutors that adapt to each student's individual learning style and pace, providing customized lessons and feedback.
That would be a game changer for education. It could make learning more engaging, more effective, and more accessible for everyone.
Exactly. And it could also help teachers by providing them with personalized support and resources.
So what about healthcare? I can imagine some pretty incredible applications there too.
Absolutely. Self-adaptive LLMs could assist doctors in diagnosis and treatment planning. Imagine an AI that can analyze massive amounts of medical data, identify patterns, and provide personalized recommendations.
It would be like having a team of brilliant medical experts at your fingertips, helping doctors make more informed decisions and potentially leading to faster, more accurate diagnoses.
Precisely. And the creative industries could also benefit immensely from this technology.
Oh yeah, I'm curious, how could AI impact creativity?
Imagine AI assistants that can collaborate with artists, writers, and musicians, helping them break through creative blocks and explore new ideas.
Wow, that would be amazing. It's like having a brainstorming partner who's constantly generating fresh perspectives and pushing you to think outside the box.
Exactly. And let's not forget about research and development. Self-adaptive LLMs could significantly accelerate scientific discovery, analyzing complex data, identifying patterns, and generating hypotheses.
It would be like having a tireless research assistant working around the clock, constantly pushing the boundaries of knowledge.
Precisely. But as with any powerful technology, it's crucial that we consider the ethical implications. As these AI systems become more capable and autonomous, we need to ensure that they remain beneficial and don't pose any threats.
That's a really important point. It's not just about developing the technology, it's about ensuring it's used responsibly and ethically.
I completely agree. We need to have open discussions and develop clear guidelines to ensure that AI benefits humanity as a whole.
Well said. Okay, before we move on to the final part of our deep dives, I have one more question that's been on my mind. Earlier, you mentioned that these expert modules are limited by the knowledge of the base model. So what if we could create base models that are inherently designed to be adaptable and continuously learn from new experiences?
That's a fantastic question. It gets at the heart of what true AI could look like. Right now, even with self-adaptation techniques, LLMs rely on a relatively static knowledge base.
It's like they have a finite library of information, even if they're good at using it in creative ways. But what you're proposing is a base model that's more like a living, breathing organism, constantly learning and growing, expanding its knowledge and abilities throughout its lifetime.
Exactly. It's a huge challenge, and it would require us to rethink how we design and train AI systems altogether. We'd need to move beyond the current paradigms and explore models that can engage in lifelong learning.
Wow, that sounds incredibly complex, but also incredibly exciting. This concept of lifelong learning in AI feels like the key to unlocking truly intelligent systems, systems that can grow and evolve alongside us.
I agree. It's a fascinating area for future research.
Well, on that note, I think it's time to move on to the final part of our deep dive. We'll explore some additional insights and questions that this research has sparked, and maybe even get a glimpse of what the future holds for self-adaptive LLMs. Okay, so we've covered a lot of ground, but there's one technical detail that I'm still a little fuzzy on. The paper mentions something called singular value decomposition, or SVD, and I gotta admit, math isn't exactly my strong suit.
No worries. SVD sounds way more complicated than it actually is. Think of it like this. It's a way to break down a complex system into its core components, like taking apart a clock to see how all the gears and springs work together.
So in this case, the clock is the LLM, and SVD lets the researchers peek under the hood and see what makes it tick.
Exactly. The gears of an LLM are represented by something called the weight matrix. That's where all the info the model has learned is stored. SVD allows them to break down this matrix and see those underlying patterns and relationships in the data.
Okay, so they're getting this X-ray vision into the AI's brain. But how does that actually help them improve the model?
Well, by selectively tweaking those core components that they uncover with SVD, they can fine-tune the model's behavior in a really precise and efficient way.
So it's not just about understanding how the AI thinks, it's about actually having the tools to adjust its thinking in a targeted way.
Right, and this ties back to what we were discussing earlier about those expert vectors and their composability. Each expert vector, which is trained using SVD, represents a set of adjustments to these core components. And because these adjustments are made in a mathematically precise way, they can be combined and reused in different combinations for different tasks.
So it's like having a set of building blocks that you can rearrange to create new structures. That's how Transformer 2 can dynamically blend different expert skills depending on what it's trying to do. Pretty clever.
It is. It's important to note, though, that SVD, while super powerful, isn't a magic solution for every situation. There might be scenarios, especially with very complex or irregular data, where other techniques might be more suitable.
So even with all these fancy tools, there's still a need for human expertise and judgment to pick the right approach. Makes sense. This whole conversation about AI is mind-blowing. The potential is huge, but I have to admit, it makes me think about the potential downsides too. As these systems become more capable of learning and adapting on their own, well, it's hard not to wonder about the risks.
I understand. It's important to acknowledge that any powerful technology comes with responsibilities. We need to ensure AI is developed and used ethically and in a way that aligns with human values.
Exactly. It's great that researchers are working on those issues, but it's also something that we, as a society, need to be aware of and engaged in.
Absolutely. Open dialogue and collaboration are key to making sure that AI benefits humanity as a whole.
This deep dive has been incredibly insightful. We've gone from the nitty-gritty details of how these models work to the broader implications for society as a whole.
We've seen how LLMs are becoming more adaptable and efficient, and we even got a glimpse of what the future might hold with AI systems that can learn and evolve throughout their lifetime.
It's been quite a journey, and for those listening who want to delve deeper, I highly recommend checking out the full research paper. It's definitely worth a read.
And who knows, maybe some of you listening will be inspired to contribute to the development of ethical and beneficial AI.
The future of AI is in our hands, and conversations like this are crucial to shaping that future responsibly. Thanks for joining us on this deep dive.